Hello, Algebra 2 students. Today we are going to do 4.8 notes. It's called Use the Quadratic Formula in the Discriminant. This is the last method to solve a quadratic equation, and that's using the quadratic formula. So the first method that we used to solve a quadratic was factoring. The second method was solving by square roots. The third method was completing the square, and this is the fourth and final method, and it's the quadratic formula. So the quadratic formula is as follows. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And that is a quadratic formula. So if you notice, you have the numerator is the bulk of the quadratic formula and the denominator is just 2 times a. So this is the quadratic formula. And you can only use it when the quadratic equation is in standard form. So when it's ax squared plus bx plus c equals 0. As much as I've said the standard form, it should be ingrained in your head that it's always, and there's always a plus between each of those terms. We will use that formula shortly. Before we do that, we're going to talk about the discriminant. What is the discriminant and what does it tell us? So the discriminant is just the stuff that's under the square root. So it is the b squared minus 4ac part. And it tells us a lot of things, believe it or not. So don't include the square root, just the b squared minus 4ac. It tells us the number and the type of solutions there will be. So whether there will be 2 solutions, 1 solution, and whether they're real or imaginary. So let's take a look at this chart. If the discriminant, if you do the math and you get a positive answer, anything greater than 0, you will have 2 real solutions. I don't know why it did that. And that means you have 2 x-intercepts. That doesn't mean you have 4 total. You just have 2. It just means the same thing. And here's what the graph would look like. You would just have 2 intercepts, and you would plot them anywhere on the x-axis. And that's something what your graph would look like. That's if the discriminant is positive. If the discriminant is exactly equal to 0, you would think that it has 0 real solutions, but it actually has 1 real solution. And again, that's not a total of 2, it's just 1. So you draw just 1 x-intercept anywhere on the x-axis. Boy, I did a really terrible job with that graph. I'm going to erase that. Maybe I'll do a better job this time. Kind of, not very. All right. And the last one, if the discriminant is a negative number, so if it's anything less than 0, that's when you have 2 imaginary solutions. You already know what imaginary numbers are. That's the definition of the square root of -1. So you'd have 0 x-intercepts. So the type of graph you would see is where the graph never touches the x-axis. So a floating parabola that can only be in the first or second quadrants, but not in the third or fourth. Because if you draw them in the third or fourth and they're going right side up, then they're going to eventually cross the x-axis. But if they're going upside down, that's a different story. You could have one like this, or you can even have one like here, or like that. You don't have to draw every single scenario, but that's what it would be. All right, let's find the discriminant in each of the following 3 problems to determine the number and type of solutions. We can't use the discriminant unless the equation is in standard form. The first one is, and automatically you know it is because the right side is equal to 0. So once you know that the right side is equal to 0, identify A, B, and C. You need all 3 of them. And then use the formula for the discriminant. So and it's not discriminant, b squared minus 4ac. Replace b with 4, because that's what you identified it as, minus 4 times a times c. Notice how I was not lazy and I replaced every single number in parentheses so that a sign will not bother me. 4 squared is 4 times 4, 16, minus, you have 4 times 6 times 11. So multiply them in whatever order you want. I would do 4 times 11 first. That's 44 times 6, 264. And 16 minus 264, use a calculator if you need to, is negative 248. So that is the value of the discriminant. So when it says find the discriminant is negative 248. Because it's negative, that means you will have two imaginary solutions. So this is pretty easy, just basic math, and then telling how many and what type of solution. Okay, the next one, notice that is not in standard form. We need to make one of the sides equal to 0. And what I like to do is, and it doesn't always mean the right side has to equal 0. If the x squared term is positive, just leave it on that side. So in this case, 16x squared is positive, so I want the right side equal to 0. So I'm going to move both of these to the opposite side. And then for the minus 9, I'm going to add 9 to both sides. So everything is going to go on the left side. So you have 16x squared minus 17x, minus 24x. What I forgot to do was combine like terms there. So minus 24x plus 9 equals 0. And now you can identify A is 16, B is negative 24, and C equals 9. Biggest mistake the students make when they're using the discriminant is they don't have one of the sides equal to 0, and then they get the value wrong. Okay, so for B, you're going to replace that with negative 24. Remember, it's always squared, minus 4 times A, which is 16, times C, which is 9. So I used a calculator. Negative 24 times negative 24 is always going to be positive, 576. And then I multiplied 4 times 16 times 9 in whatever order I wanted. So I did 64 times 9, which is also 576. And 576 minus 576 is equal to 0. So your discriminant is 0. Therefore, you have one real solution. And lastly, the only thing that's keeping this from being in standard form is the negative 32, which needs to be moved and added to the left side, and it needs to go under the constant because like terms go under like terms. So you have x squared plus 15x plus 56 equals 0. A equals 1, B equals 15, C equals 56. My students usually master knowing A, B, and C just because we do it so many times. And practice makes perfect. So B squared minus 4AC, replace B with 15, square it, minus 4 times 1 times 56. With such large numbers, you would be crazy not to use a calculator. 15 times 15 is 225, minus, 4 times 1 is 4, times 56 is 224. That equals 1. So your discriminant is 1 because it's a positive number. You have two real solutions. Hopefully that wasn't too painful. That's the first part of the notes for 4.8. The second part of the notes is using the quadratic formula. Now this takes a long time. So students are like, we don't really like the quadratic formula. Unfortunately, sometimes when you can't factor, when you can't use the square root method, when you can't use completing the square, never told you, but completing the square only works best. I would only use it if the B term is an even number, because you don't want to take half of an odd number. And then you have ugly fractions, decimals, so on. But the quadratic formula works for any quadratic. So you can use it for every single problem we've done in the last few sections. for when you had to solve quadratics. But we are going to use the quadratic formula, so I'm going to write it up here again. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. And there's our formula. So we'll use that. Instead of me writing the formula every time I do the problem, we'll just refer back to that. All right. Again, we can only use it when the equation is in standard form. And notice number 1 is not in standard form, but 2 is. So let's look at number 1. Number 1, the 4x squared is on the left side, but there's an x squared on the right side. You want the x squared term to be positive if you can help it. So I'm going to move both of these terms on the right side over to the left side. So subtract x squared underneath here, and then put the plus 7x somewhere over here. So you have 3x squared, you want to write small here, plus 7x plus 3. I should have put the 7x right in the middle, but whatever, equals 0. There, now that is decent looking. It's in standard form. Now that it's in standard form, let's identify a, b, and c. A equals 3, b equals 7, c equals 3. The part that students don't like is it takes so much room. So just be really, really cognizant of your space and use this middle section if you need to. So now with the formula, x equals negative b. So we identified b as 7. So we want opposite. So negative 7. That's what negative b means. Plus or minus the square root. You know what? We should just make a big fraction like this. So we know the only thing that goes on the bottom is a simple 2a. So now we have b squared. So b is 7. Square it. Minus 4 times a times c. Make your bar long enough. All over 2a. 2 times 3. And from that point on, it's just math. It's just doing basic stuff. Use a calculator when you need to. Negative 7 plus or minus 7 squared. Now, if you call it 14, that's on you. So 7 times 7 is 49. Minus 4 times 3 is 12. Times 3 is 36. All over 6. Right. So equals negative 7 plus or minus 49 minus 36 is 13. Yep. All over 6. Notice the 13 is a positive number, so you know you're going to have two solutions because the discriminant is 13. So that number tells you we're going to have two real solutions. Not that I asked, but at the end, when you're done solving for x, you better have two answers. Okay, now let's split them up into our two answers. So x is equal to negative 7 plus the square root of 13 divided by 6. And the other answer is x equals negative 7 minus the square root of 13 over 6. That's what the plus or minus means. Now, if you used a calculator, and I think I asked you on your worksheet to approximate, these are the exact answers. And when I say in the directions, write your answer as a decimal approximation. You want to use a calculator, figure out what the square root of 13 is. Whatever it is, it's going to be close to 4 because the square root of 16 is 4. So it'd be negative 7 plus some 3 point something divided by 6. So this will give us about negative 0.57. And the other one will give us about negative 1.77. Now, which one is a better answer? The exact answer is always better. So if I give you the directions on your homework to give decimal approximations, just ignore it. It just all depends on what kind of calculator you have. All right, for the next particular one, it's already in standard form, so that's awesome. We can identify A, B, and C. There's our formula. Let's go back to it. So x equals negative b. B was negative 10, so negative b is a positive 10, plus or minus all over 2 times a. So we might as well just put 2a, 2 times 5 here. So in the top, we have b squared, so negative 10 squared minus 4 times a times c. I never make my fraction bar or my radical long enough. There we go. And students don't do that, and then they get them wrong. I was like, why is it that some of the stuff is missing from the numerator? Make your bar long enough. It's okay if it's too long rather than it being too short. So we have 10 plus or minus negative 10 squared. Anything squared is going to be positive. So this first number is always going to be positive. Second number, it depends. In this case, you only have one negative sign, same like with the other problems. So that's 4 times 5 is 20. 20 times 24 is 480. All over 10. So that's 10 plus or minus negative 380 all over 10. Now, hopefully you notice the discriminant is negative, so you're going to have two imaginary solutions because you can't take the square root of a negative number in the real number system, but you can use imaginary numbers. Let's move that over here. All right, negative 380 is a very large number. And remember, we're going to compensate for the negative by putting an I in front. Okay. So I'm going to go ahead and take care of that. And I'm going to break down 380 as 4 times 95, and that works. So radical 4 times radical 95. Thing is, can we break down 95 even further? So you kind of have to question yourself. 95 is divisible by 5. And so if you divide 95 by 5, you get 19. So here's the thing about 95. 5 times 19 is 95, but both of those are prime numbers. So 95, believe it or not, does not break down any further. All over 10. So that's 10 plus or minus I, 2i, because the square root of 4 is 2, times radical 95 all over 10. And now let's separate it into our two answers. So the first answer, well, let's simplify it. So we can write it like this. Because we write each part of the numerator over the denominator. So 10 divided by 10 is 1. Plus or minus 2/10 is equal to 1/5. And you could put the I in front and then put the radical, or else you might actually put it in the radical. And those are your two answers. These are two answers. One answer, I should have put x, so x equals. So one of your answers is x equals 1 plus 1/5 I times root 95, and the other one is x equals 1 minus 1/5 I root 95. So there are two solutions here. I'm too lazy to write them out separately, and it tells you that there's two. All right, our last one. All right, the one of the sides is not negative, and obviously the easier side to make, or I'm sorry, it's not equal to 0. The easier side to make equal to 0 is the right side because there's only one number to move. So let's add 2 to both sides. 8x squared minus 8x plus 2 equals 0. A equals 8, B equals negative 8, C equals 2. We have plenty of room here to use the quadratic formula. So x equals negative b. Okay, this time I'm going to make my fraction bar so long, I'm not going to run out of room. All over 2a, so 2 times 8. So the first number that goes in the spot is negative b. Well, we identified b as negative 8, so a negative b is positive 8. Always the opposite there. Plus or minus there, b squared, and that's negative 8 squared, minus 4 times a times c. Yay, I made the fraction bar long enough. All over 2 times 8. So we have 8 plus or minus. I'm going to do the 2 times 8 first. 8 times 8, or negative 8 times a negative 8, doesn't matter. It's still going to be positive, 64. Minus 32 times 2 is 64. 64 minus 64 is 0. Notice everything stays under the square root until you're ready to take the square root of it. So don't lose that square root sign. Notice when the discriminant is equal to 0, you have one real solution. So you're only going to have one answer in this particular quadratic equation. So we have 8 plus or minus, the square root of 0 is just 0 over 16. So take a look at this. So x equals 8 plus 0 divided by 16, or x equals 8 minus 0. It doesn't matter if you add 0 or subtract 0. It doesn't change the answer. So here, that's 8 over 16, which is 1/2, which is 1/2. And you only have one answer. So that you don't use a duplicate. So you have x equals 1/2 as your answer. Or as a decimal, it'd be x equals 0.5. When you're dealing with imaginary numbers like example 2, there are no decimal approximations. All right, let's do a real life application of using a quadratic formula so you know where it's useful. A juggler tosses a ball into the air. The ball flying in the air is modeled by the equation h equals negative 16t squared plus 40t plus 1. Now remember, negative 16 you get from the acceleration due to gravity. Just imagine a juggler, and you know how the ball goes. It's a parabolic path. The ball is released from the juggler's hand, goes up, comes back down, and then so on. How long is the ball in the air? So that this is what you're trying to answer. Is there an extraneous solution? Remember, extraneous means false solution. So we are going to use the quadratic formula. Notice it's in standard form. Now h, remember how long the ball is in the air. You can just ignore the h portion because you're only interested. That's kind of like the x equals negative b plus or minus whatever. So don't worry about the h being there. You can identify a as negative 16, b as 40, and c as 1. And now we're going to use the quadratic formula. Instead of, basically what you're doing is instead of x equals, you're doing h equals. So h equals negative b all over 2a. Equal sign. So negative b is negative 40 plus or minus square root of b squared, and b is 40 squared minus 4 times a times c. If you're going to be lazy and you don't use parentheses, that's on you. And you're going to be very sorry when you take your test and I give similar answers and I just barely change them by a negative. So you have to be very, very careful. Okay, so here we have negative 40 plus or minus 40 times 40 is 1600. Oh, here's the first time we have two negatives. So you have a negative times a negative. That's a positive 64. Anytime you have an even number of negative signs, it's going to be positive. If all three numbers had been negative, it would have been negative. All over negative 32. Okay, so this is negative 40 plus or minus 1,664, or negative 40 plus or minus the square root of 1,664 all over negative 32. That's h. And now let's split it up into two equations. We know there's going to be two real solutions because the discriminant is positive. So h equals negative 40 plus the square root of 60 plus the square root of 1664 over negative 32. And the other answer is h equals negative 40 minus the square root of 1664 all over negative 32. Here you want to use a calculator and determine what the square root of 1664 is, and whatever that is. And once you know what that is, you add it to negative 40. So, and then divide by negative 32. Here I ended up getting about negative 0.02. And here I did the math and I got h was about 2.52. And how did I get a positive answer on the second one? Because you have -40 minus. Well, the square root of 1,600 is 40. So the square root of 1,664 is going to be a little more than 40. So it's like -40 minus 41. Let's just say it's minus 41 over -32. So you have a negative divided by negative. It's a positive. There is an extraneous solution, and it's this one. You can't have a negative time. Actually, this should have been my bad. I'm gonna go back and erase something. You don't have to erase much, but I can erase that, 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 and that, and that. Because we're solving for time, t. So I don't know what I was thinking there. So you could just put it all the way through. We weren't solving for h. I don't know what I was thinking. So you can't have negative time. So negative 0.02 is a false solution. It's an extraneous solution. If you didn't have a word problem, you would say both of those were correct. But because this is a real life application and you know that there's no such thing as negative time, you only have one answer and it is 2.52 seconds. So in about 2.5 seconds, that's how long the ball will be in the air. And those are your notes for today. Have a great day, Algebra 2 students.